Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the development of surfaces of solids. I am Dr. AIP Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now, today's discussion will be about development of truncated hexagonal prism, and the development of the truncated hexagonal prism will be carried out using the parallel line development method. Now let us read out the statement. A hexagonal prism, side of base 20 millimeter and axis height 50 millimeter. So here the axis height is equal to 50 millimeter and the side of edge of the base, this is equal to 20 millimeter. It is resting with its base on the horizontal plane such that one of its rectangular faces it is parallel to the vertical plane. So here we can see this rectangular face, it is going to be parallel to the vertical plane, and since this hexagonal prism is resting on the ground on its base, so in the top view, that is onto the horizontal plane, we are going to obtain the true shape of this hexagon over there, right? So in the top view we will be obtaining the true shape of this hexagon as its top view, right? Then it is cut by a cutting plane which is perpendicular to the vertical plane and it is inclined to the horizontal plane at an angle of 45 degree. That is, this is an AIP which is going to cut this particular hexagonal prism, and this cutting plane is going to pass through the rightmost corner of the prism. So this will be the right corner of the prism. So this cutting plane, usually you see we are given that the cutting plane cuts the axis of the prism at this particular point, but here we are provided with the information that this cutting plane passes through the right corner of the prism. So this cutting plane, you see, it passes through this right corner, and the angle of inclination of this cutting plane with respect to the horizontal plane happens to be 45 degree over there. And now we can see this cutting plane, it cuts all the vertical edges. You see, these are all the vertical edges. So it passes through all the vertical edges of this particular prism. Therefore, 6 points of intersections, they are going to be there between this cutting plane and this hexagonal prism that we have. So we are required to draw the sectional top view development of the lateral surfaces of the truncated prism over there. So in this case, while we are trying to solve the problem of development, so the principles of projections of solid, then the section of solid, and then the development method will be used in order to obtain the final solution. So before we start with the solution, so first thing we need to understand which is the appropriate position of the hexagon which will be drawn below the XY reference line, that is in the plan on the top view. So if we draw the hexagon in this orientation, you see none of the edges of the hexagon, they will be parallel to the vertical plane. So if I draw it in this orientation, then I won't be getting any one of the edges or the rectangular faces of the prism parallel to the vertical plane. So this is the incorrect, you see, position of the hexagon onto the horizontal plane which is to be drawn, and this is the appropriate position of the hexagon. That is, if I draw hexagon in this orientation, one edge or one rectangular face of the hexagonal prism will be parallel to the vertical plane. So this orientation is correct, and this one, it is discarded because it is incorrect. Now let us start with the development of the truncated hexagonal prism. So first of all, we draw the XY reference line as usual. So to begin with, I have to draw the top view of this hexagonal prism below the XY reference line, because in the top view I am going to view this hexagon as my top view projection onto the horizontal plane. And the orientation we have discussed, that one edge of this hexagonal prism or the one rectangular face of this hexagonal prism will happen to be parallel to this vertical plane, right? So let us draw the hexagon projections. So these are the projections of the hexagon. Edge of the hexagon, we know this is equal to 20 millimeter. So using 20 millimeter edge length, so we have drawn the hexagon over here, and the numbering of all the points, it has been done. So the first vertical edge is A1, the second vertical edge, it's B2, then the vertical edges they follow, they are C3, D4, E5 and F6. Now having drawn this top view, now we need to work out the axis. So in order to work out the axis, we have joined all these diagonals light. So you don't have to join them dark because it is not a pyramid, it is a prism. So it is only for the purpose of identification of the axis point that we have joined all these diagonals. So these have to be joined using 2H pencil or the lighter line, thinner line. Now having drawn this axis point, now you see O and O dash, O and O1 points, they have been located for the axis. So this is the top view. So O point will be the top of the axis, that is on the top face, whereas O1 dash point will be corresponding to the bottom point on the axis. Okay, so now having drawn the axis, now I know the height of the axis, that is the length of the axis, is equal to 50 millimeter. So once I know that this is my axis height, now I can draw the front view of this prism over there. So you draw the projections, and the projections will give you the front view of this hexagonal prism. And once again, let us label the points over there. Here the top view we have labeled as 1, 2, 3, 4, 5, 6. So we have 1 dash and then 2 dash, 6 dash corresponding to this generator, then 3 dash, 5 dash corresponding to these 2 points, and 4 dash point lies over here. And correspondingly, the bottom points, they have also been located over here. So the projections of the base point, they have been located on the XY reference line, and the projections of the top face, they have been located at the axis height, which is equal to 50 millimeter. Now having drawn this front view projections of the prism, one thing we need to be very much clear, please see the projections corresponding to F6, that is 6 dash, F dash in the front view, they will be dotted because the edge, vertical edge F6 is lying at the back side. But these projections of 6 dash, F dash, which happen to be dotted projections, that are the hidden line, they have been superimposed or covered by the projection, that are the object line or solid line projections of the projectors corresponding to B2 or 2B. So we can say that the projections of 2 dash, B dash, they will be of solid line or the object line, whereas the projections corresponding to 6 dash and F dash, they will be dotted. But the dotted projections of 6 dash, F dash, they have been covered by the solid line projectors of 2 dash and B dash over there. That is why we get a solid line over here. Similarly, the projections corresponding to 5 dash and E dash, because this is the edge E5, this is again lying at the back side. So the projections in the front view should be dotted, that is 5 dash, E dash projections should be dotted, but these dotted projections, they have been covered by the solid line or the object line. You can see this is the solid line or the object line projections corresponding to the edge C3. So this is C3 edge, it is going to cover the projections of E5 edge over here. So that is why these projections, they will superimpose the dotted line projections of the E5 or F5 dash and E dash over here. So that is why again we get a solid line projections over here. So we have not drawn the darker lines in the front view because this portion is going to be cut by a cutting plane. Now let us work out the location of the cutting plane. The cutting plane, it is perpendicular to VP and inclined to HP at an angle of 45 degree. That is AIP inclination with HP is at an angle of 45 degree. And this AIP passes through the right corner of the prism. So which is the right corner of the prism? This one. So it passes through 4 dash, right? So cutting plane, that is AIP, will be passing through this point, that is 4 dash. Let us draw the orientation. So just see, we have drawn this orientation of the AIP. This is inclined with respect to HP at an angle of 45 degree, and it passes through the right corner of this particular prism. So as I told you that since this cutting plane is going to pass through all the vertical generator, you see generator 4 dash D dash is being cut, generator 3 dash C dash have been cut, generator 5 dash E dash has been cut. Similarly, the generators 2 dash B dash, 6 dash F dash and 1 dash A dash. So all the 6 vertical, you see, edges, they have been cut over here. So all the vertical edges, so these are the vertical edges. So all the vertical edge generators, they have been cut over here. So that is why 6 points of intersection, they are going to lie onto this cutting plane. So let us work out the names of those points. You see, again keeping in view the parity, 1 and A dash, wherever it has been cut, we will call that POI name as 11 dash. 2 dash and B dash, wherever it is cut by the cutting plane, the name of point of intersection will be 12 dash. Similarly, 6 dash and F dash, it is cut at the same point, so this name of POI will be 16 dash. Similarly, 3 dash C dash has been cut by the cutting plane at a point of intersection which is given the name 13 dash, so that we are easily able to locate all those points onto the development as well. Similarly, the vertical edge 5 dash E dash will be cut by the cutting plane at the POI name 15 dash, and finally 4 dash D dash will be cut by the cutting plane at a point whose name is given as 14 dash. So the front view POIs, all of them, they have been named and they have been located and identified onto the cutting plane. So having located these points over there, now we have to draw the projections of all these points in the top view as well, right? So let us work out the projection. You see, point 11 dash, that is POI, point of intersection of the cutting plane, with 1 dash and A dash, it lies on the vertical edge, that is 1 dash A dash. And if I look at this point, so this 11 dash point lies on the vertical edge. So obviously the projection of the vertical edge was A1, which was appearing to me as a point view. Why? Because this edge happens to be a, you see, perpendicular edge to the base basically. So if any line of, if any edge happens to be perpendicular to the base, so the projections of that edge onto that plane, that is onto the horizontal plane, will give me a point view. So since point 11 dash is lying on the same vertical edge, so it will again coincide with the point view of A1. So similarly, again 12 dash is lying on vertical edge 2 dash and B dash. So again 2 dash, 12 dash and B dash, they lie on one vertical edge. So their top view will again coincide, because I am going to get point view in the top view. So you see, B, 2 and 12, they will again form a point view. Similarly, 13 point, that is 13 dash, lies on the vertical edge 3 dash and C dash. So I am going to get a point view in the top view corresponding to all these 3 points. So 3 dash, 13 dash and C dash, they all coincide in the top view because I am getting a point view. Similarly, 14 point, it is again going to coincide with the projections of D and 4. 15 point, it is again going to coincide with the vertical projector of E5. And 16 point, it is again going to coincide with vertical projection of 6 dash and F dash, because now 6 dash, 16 dash and F dash, they all 3 points, they are lying in the same vertical line over there, which happens to be perpendicular to the horizontal plane. So now all the 6 points, they have been located, and it has been observed that all the POIs, they are going to coincide with the edges of this particular prism over here. So wherever the first 2 points were lying, the third point is also lying over there. So looking from the top, all these 3 points, they will project at a same point, right? So we have obtained the POI locations in the top view. We have located the POI locations in the front view. Now let us darken the remaining portion of the solid, which is the uncut solid. So since this solid has been cut by a cutting plane in this orientation, so this portion, now we assume that this portion has been omitted, so this has been discarded, so we are left with the remaining portion of the solid over there. And for this remaining portion, the POIs in the front view have been identified, POI in the top view they have been identified, and since they are all lying on the, you see, edges of the base over here, so now we can shade this portion, because this total portion is our section top view. You see, we have this big a section view, right? So the cut section is this big, so which is passing through all the vertical generators or the vertical edges. Now we can shade this, and this is our sectional top view. So we were required to draw the sectional top view first of all, and then now we are going to start with working on the development of the lateral surface of the truncated prism. But before that, we were required to evaluate the section top view. So please see, section top view has been evaluated. So you do the shading. So shading will be at an angle of 45 degrees with respect to this XY reference line. Now, as I told you earlier, we are going to carry out the development of this truncated hexagonal prism using parallel line development method. And what is the parallel line development method? From the two ends of the solid, you see, this is one end of the solid, that is the base. This is second end of the solid, that is the top face. So this is top face of the solid, this is base of the solid. So these are the two ends of the solid. So from the two ends of the solid, you see, I am going to draw two stretch lines. So these names of these lines, they are the stretch lines. So two stretch lines will be drawn from the two corners, from the base as well as from the top face. And once we draw the two stretch lines, and mind you, this height is a true length. So in any development, all the dimensions which are drawn, they will be corresponding to the true lengths over there. So please see, the true length of the axis height is equal to 50 millimeter. So the distance between these two stretch lines, this is also 50 millimeter. Now I need to draw all the lateral edges over there, and between these two stretch lines, all the lateral surfaces, they will be marked over here. So let us say I am going to start from this vertical edge, that is A1. Please see, I am going to start from this vertical edge, which happens to be A1. And since this is A1, so one vertical length I am going to draw corresponding to this vertical edge, which happens to be A1 over here, right? And then I am going to measure this total length. So total length is how much? You see, one edge is equal to 20 millimeter, and 6 edges are there in any given hexagonal prism. If I take the circumference of this, so the circumference will be 6 multiplied by 20, that is equal to 120 millimeter. So this length I am going to mark as 120 millimeter, and the height will be equal to 50 millimeter, and this is again a true length. So 20 millimeter is true length of the edge. Now between these two ends, now I am going to mark 6 edges at a distance of 20 millimeter each. So please see, at a distance of 20 millimeter each, I have marked one face. This is my first rectangular face, you see, at the back side. Second rectangular face, third rectangular face, fourth rectangular face, fifth rectangular face, and the sixth rectangular face. So now I am going to put down the points. Since I am starting from A, please see, I will be moving along this direction. Start from A, go to B, go to C, then D, then E, then F, and then get back to A. Usually many people or students, they make a mistake. They start from A, go to B, C, D, E, and then F. They stop at F. If you stop at F, only 5 surfaces you see. One surface, 2, 3, 4, 5. So we are going to miss out on the 6th surface. So the 6th surface will ensure that I am going to cut the solid over here. So this is basically the joint. So where from you start, after cutting the solid, you reach the end point. So this will become my joint over there. So at this point, my joint of this particular sheet metal will be coming out. So you start from A, then B is encountered, then you encounter C, D, E, F and get back to A. So please see, we have got A and then 1, B and then 2, C and then 3, D4, E5, F6 and again A1. So having worked out this lateral surface, this is the lateral surface of the development of the uncut, that is non-truncated hexagonal prism. So had there been no cutting over there, this would have been the development of the hexagonal prism without cutting. Now since this prism has been cut, so one by one, you see I have started from this point A. So one by one I am going to pick up all the cutting POIs. You see these are 6 POIs. So these 6 POIs will be located onto this, you see, flattened surface which has been obtained over here. So how to do it? From every POI, you see this is one POI point, this is second POI point, this is third POI point, this is fourth POI point. So from points 1, 2, 3 and 4, draw the horizontal lines through these 4 points over there. Okay, so I have drawn these 3 because fourth one is already existing over there. Now I'll be starting from this point. I want to locate 11 dash point over here. So where does you see 11 dash point lie? 11 dash point, it is going to lie on, you see, vertical edge which happens to be A1, right? So where does it lie? It lies at a distance of this much above the horizontal plane. I know the height of this point. Now I am going to locate this point on the edge A1. This is my edge A1. So again A1 is appearing because I have started from A. Okay, so I'll be marking my point 11 over here. This is my point 11. Similarly, I get the location of this point 11. Again I repeat, this point POI is available as a result of the intersection of the cutting plane with this vertical edge, that is 1 dash A dash. I know the height of this edge above the horizontal plane. So what I'll be doing, onto this horizontal line projector, I'll find out where does A1 edge is going to lie. This is my A1 edge which is lying on this place. And since I am starting from 1, so it is repeated twice. So that is why point 11 has been marked twice over here. Starting point as well as the end point. Had I cut from B, so whichever point B was intersected, so B would have been here and B would have been here. Okay, so since A1 is my starting point, and you see in development it is your sweet will. You can start from B2, you can start from C3, you can start from D4, you can start from E5 or you can start from F6. So any corner or the edge you can pick up as a starting point. So I have picked up my starting point as A1. So if A1 is my starting point, so this will be start and this will be the end point. Now the location of first POI has been located at the start and at the end. Now the second POI, I am moving like this, so I'll be marking all the points in the same order. The second POI is lying on the vertical edge which is B2. And what is the name of that point? 12. So let me see the location of that point in the front view. This is my 2 dash B dash vertical edge in the front view. The height at which it is being cut by the cutting plane, it is this distance above the horizontal plane or above the XY line. Now this is my 12 point. Now I'll be taking horizontal projector, find out where does my vertical edge lies, that is 2B. So just see my 2B edge is lying here. So I'll be marking my point 12 over here. And please check, only first point is repeated twice. All other points they will be appearing only one, because one edge has been cut at only one place. So this edge also has been cut at one place, but the starting and the end point has to be same. That is why this point is repeated twice. So the second edge you can see it has been cut over here. Okay, so it has been located here. Then third edge, you see this is this one. This edge is which one? 13 POI is there on the vertical edge C3. So let me work out the location of this 13 point onto the front view of the vertical edge 3 dash C dash. You see this is my vertical edge 3 dash C dash. So I have located this point 13 dash. Again, now I'll bring the horizontal projector, find out where it intersects with the vertical edge 3C of the development. So this is my 3C edge of the development. So I have located point 13 over here. Then next I am moving like this. Now next I encountered point 14. It lies on the vertical edge D4. And let me work out where does it lie on 4 dash D dash. It lies on the top, because my cutting plane was passing through the top right edge of this particular prism. So here 14 dash point lies here. I'll bring this, find out where does my 4D lie. My 4D lies here. So 4 and 14 point I have been marked over here. Then next point, as I'm moving in this anti-clockwise, E5. So E5 is being cut by POI at a point 15. So the location of 15 dash is here. So bring this projector in the horizontal position, find out where does this horizontal projector intersects the vertical edge 5E in the development. So it is over here. And next, last point, 16. So where does 16 point lie? It lies on the vertical edge F6. So from 16 dash, which is lying on 6 dash and F dash, now I bring the horizontal projector, work out the vertical edge 6F over here. So all the 6 points of intersection have been appropriately located in the development view as well. Now what needs to be done? I'll be joining all these points and then the base also, and then at these points you see the folding is going to occur. At these points the folding will be occurring wherever it has been cut. So again these points also have to be darkened, because they are going to interpret the vertical sections of this particular bend. So these vertical lines, they are going to represent the bends over there. There is change in cross section, change in surface, that is why this bending will be there. So this bend will be indicating that there is a distinct change in the surface between one rectangular surface and the other rectangular surface, right? So this way, so step by step we have been able to work out how to make a development of a truncated hexagonal prism, and we have done it using the parallel line development method, right? So this is all for today. So we have been able to work out how to develop the development of a truncated hexagonal prism. So we'll be continuing with further discussion on few more problems related to the development of surfaces in our coming lectures over there. So thank you very much. Thanks a lot. Thank you.